welcome back. Second of the videos in having an X on both sides of the equations. If this is the first time you've seen me teaching equations, there's a previous playlist that builds up to this, which is the simpler and more basic forms of them. Let's have a look at what's going on here. What I'm going to nag about is the same things all the time. I call them the obs, which is the opposites to both sides. On any equation, anywhere, we want to balance them up. If I add 2 kilograms to this side of the scales, it would make the scales go down. To balance it up, it's getting 2 kilograms on the other side. If I add 2 kids on this side of the seesaw, or add 1 child on this side of the seesaw, if I add a child who's about the same weight on the other side of the seesaw, it balances up. If I take one off one side, it unbalances it, and so to balance it up, you have to take one off the other side. If I halve each side, same principle. So opposites, when you do it to one side, you do it to the other side. What makes this stand out more than any other concept that's involved in this question is there's an X on the left hand side of the equals, on this side of the equals, and there's an X on the right hand side of the equals. We don't want the equation to say X equals something X, we just want the equation to say X equals. So what we're looking at is getting the equation to tell us the answer. So we don't, I really talk about we don't have to think. You can talk on my Year 12s yesterday. I was talking about the fact that a lot of what we do is so you learn the process, you don't have to think. Over the years, students have fought, many students have fought, probably not thousands, but I have taught thousands of students. There would be quite a significant number who would just not want to do what I said and wanted to do different methods. I will compromise and teach you a lot of things once you get the hang of it, if you were in my class. And if you say, and then I'll say if you prefer this method, it's better than that method for this reason, and talk about it. But for those of you who want to just accept what I'm going to say at the moment, get rid of the X on the right hand side. How can I get rid of a 2X though? They're joined together. I can't just remove the X. If I take 2X from that side, I get that whole term removed. Remember, we talk about these are terms. Terms are separated by pluses and minuses or equals. So there's 2 terms here, there's 2 terms there. Technically, in a way, you could say there's 4 terms altogether. So if I take 2X from the right hand side of the scales, take 2X off the left hand side of the scales, remember it's not 5 take 2 equals 3, it's 5 X's take 2 X's. By the way, if X happened to be 10, it'd be 50 take 20 would be 30. So maybe your brain struggles with the idea of what's actually going on with the X's. If that was a 10, that'd be 50 take 20 would be 30. If it was 11, it'd be 55 take 22 would be 33. So we're trying to figure out what the X is, and in real life, it's everywhere, and everything we do, every calculation for everything is working out an answer, or we talk about a solution to our problem. So I've got a 5X take a 2X is a 3X plus a 3. 2X take 2X is gone. I could say 0, I like to say gone, equals 5, and now we're back to simple equations. If we got rid of that 3 first, the problem would be it quickly introduces fractions in the questions. Wouldn't be too bad on this question, but let's just have a look for the moment. If I get rid of the plus 3 first, I get from the left hand side, I also do it to the right hand side. So we're trying to get the X by itself. So I could get rid of that 3 first by going divide. If I divided there, I'd have to divide there, I'd have to divide there. So now I'm left with just the 3X because 3 take 3 is gone and 5 take 3 is 2. And everyone's favourite topic, between the 3 and the X is a times. So how do I get rid of times by 3? I divide by 3 and I divide by 3, and the answer is 2/3, which I was talking about everyone's favourite topic. Quite okay, but it's just 2/3. People want to write 0.6 repeater and also cut off the decimals. Trouble is if you cut off the decimals and you write 0.6, you're actually incorrect. You're actually quite very rough incorrect. Some people would write 0.7, still incorrect. It's rough, but too incorrect. If you had 0.67 and you stipulated that you use 2 decimal places, probably be okay because it's actually correct to 2 decimal places. But it depends on the question I was asking for. Better most of the time just to leave it as fractions, because fractions are what we call an exact answer. So if you want the accuracy later on, the exact answer is more accurate for your calculations. Okay, this one over here, quickly through the process. I want the x to only be on one side, so I'm going to remove it from this side. If I remove it from the right hand side, I remove it from the left hand side. Now, so I have seen people over the years go, x take x is gone, so they're left with 4. It's not that. It's actually 4x take 1x is 3x plus the 1. The x take the x is gone. Be careful here. You've still got the minus. So that minus just doesn't disappear. It's actually a -6 in that sense. So now if I get rid of the minus 1, the plus 1, I go minus 1 to the right, I go minus 1 to on the left, I go minus 1 to the right. I'm left with a 3x because the 1's disappear. Now the trap here is the -6 minus 1. I know a lot of students struggle with it. So if we start at -6, all that means is we go down 1. So if I went down 1 from -6, it becomes -7. So there's where we go. Down 1. -6 minus 1 is not two negatives becoming a positive. It's just moving up and down a thermometer or a scale. So now I've got a -7. Here's where people tend to go wrong. If I divide this side by 3, I divide that side by 3. Not only do we have a negative answer, we've got fractions as well. Technically, that's the answer to the whole question. But you will have teachers, and I have expected over time, that students change that into whole numbers as well as fractions, which we call mixed fractions. 3 goes into 7 twice, and there's 1 remaining. So 3 and 3 is 6. There's 1 remaining. If we started with thirds, we end up with thirds. And don't forget, if we started with negatives, we end up with negatives. This one here, what makes it different is I didn't write the x at the front. It's like, you see question after question written the same, and we suddenly make it look different. I get rid of that 2x there. I go take 2x on the other side, opposites to both sides. Don't want the x on this side, so get rid of it. I could have gotten rid of the 4x on this side, but on this one it's obviously easier to end up with just the 2x here. So I've still got the 3, but I've got the 2x. 2x take the 2x is gone, I'm left with a 1. Now the traps that happen. Students are used to going take 2, but that 2 is connected to the times, to the x by a times, by a multiplication. So I could go divide 2, divide 2, divide 2. But if you look at it automatically, you've got fractions, and fractions tend to cause people more problems. So the 3 at the front is still just a 3. How can I remove 3? I take 3 from the left-hand side, I take 3 from the right-hand side. 3 take 3 is gone, so I'm just left with 2x. 1 take 3, you're taking away more than what you had. Could go back to a thermometer or scales and talk about what it is, but that's a -2. What's between the 2 and the x? The times. How do we get rid of a times by 2? Divide by 2, divide by 2. And the answer is 2 into 2 goes once. How many negatives do we have? Now remember, 2 negatives will make a positive, but we've only got 1 negative, so the answer is x equals -1. Last one, basically the same as that, but we've got the brackets as well. So the 3 ones are 3, the 3 times x is a 3x. And you go, well, how many negatives have I got? This is a positive times a negative is a negative. 2 times the 2 is 4 with the x. So we're doing a multiplication here. So it means multiply everything in the bracket by 2. This one was multiply everything in the bracket by 3. So 2 3s are 6. There's no negatives involved, so it's an addition. It was an addition. It stays an addition. Now, we want to get the 4x removed from the right-hand side. I do know, it's really nice often, if I want to get rid of that -3x here, it all becomes positive on that side. There are so many other shortcuts as well, but we won't get there today. Here we go. I'm going to stick to going take 4x, take 4x. For those of you who are like a habit and the same procedure each time, I'm going to stick at that for the moment. So now we're left with 3. If you're -3 and you're -4, we are going down 4 from -3. So I could start here at -3 and go down 4. And I end up at -4, -5, -6, and -7. So that's -7x. The 4x take the 4x is gone, and then we've got a 6. Now I could go, this is where it really becomes revolting, divide -7, divide -7, divide -7. That's why I've been nagging over many videos now to say, don't do the division first. The minus 7 is multiplied with the x, it's connected to the x. So instead of that, it's easier to get rid of the minus 3 first. So I'll get rid of 3 first, I should say, by going minus 3 this side, minus 3 that side. Now, don't forget, a lot of students will just write 7x equals 3, and they won't realise they're wrong. You get a test back and you go, oh my goodness, I got it wrong. And you don't know why you got it wrong till afterwards. It's still got that minus there. So you could say it's a negative 7x. So there's the negative still there. So we use negative and minus interchangeably. Now I can get rid of that by going divide by minus 7. If I do it to the left-hand side, I do it to the right-hand side. By the way, how many times does a minus 7 go into a minus 7? It fits in once. So you can see why the two negatives have to become a positive. Because they fit into each other how many times? Once. I don't have to write the 1x, I can just put the x. And the answer is just 3 on 7. But instead of being a positive 3 on 7, it is a negative 3 on 7. Now can you imagine putting that back into here and trying to see if you're correct? It's messy. So in the long run, this is the first time we're starting to get serious about getting, I'd call them revolting answers, but it's just a bit harder answers than the simple ones like 1, 2 or 3. In the next video, we'll go a step further and make it a little bit more complicated and show you, once people get the hang of it, what we do as teachers to then make it more challenging.